And good afternoon. How's everybody doing today? Dr. Roddenberry coming to you live from Willow Springs, North Carolina on a hot September afternoon. Good afternoon, Elisa. Good to see you. Jenna, good to see you. Jenna Ramuni, good to see you as well. How's everybody doing today? If you're here in the chat bar and you haven't had a chance, go ahead and say hello in the chat bar. Let me know you're doing well. It's good to see everybody. And Lisa, thank you for always bringing cheer into the chat bar. Your entrance today into the, oh, no, goodness me, was rather stunning today. Excuse me for doing that, but I'm seeing it on the camera and I'm not going to memorialize that forever. I'm doing fine. Thank you very much. You know, before we get started with today's lecture, I did want to talk about writing assignment number 1 briefly before we get started. Now, this message is for my live students. Those of you who are in class right now, this is primarily for you. Now, there are going to be students watching this in a recorded format. If you're watching this in a recorded format, another semester or maybe later on in the semester, these dates probably don't apply to you, but do know I'm going to be talking with you regarding the same issues if you are watching recorded lectures. So I'll go to my notepad. Now, remember, this is for assignment 1 for fall 2023, actually the first 8 weeks. The grading will be completed by tonight. That is September 7th. Sometime by midnight. I've got about 15 or 20 more left to grade. I had about 70, so I've been working on them, and I've got them done. I'll have them done by midnight tonight. The second thing is a good number of people are going to receive a grade of 1, which does not meet expectations, rather than 2 meets expectations. If you get a grade of 1 does not meet expectations, please read the feedback on the assignment. Go to the course material, make the changes on the assignment, and resubmit a new attempt in the same location as the first submission. And what I'm going to say is most people really weren't focusing on the specific types of research methods and the links those research methods have to our ability to make statements of causality. I want you to focus on Hereditary Genius PowerPoint 1, slides 7 through 9 for this assignment. And we want to focus on those specific methodologies of case studies, correlational studies, and experiments. Now, here's the thing. Some of you mentioned observations. Now, observations is listed as a research method on PowerPoint 1, slides 7 through 9. However, I'm going to tell you that observations, be it natural or laboratory observations, are the basic level of sort of descriptive science. In this sense, we are just looking at things. So, for example, I could go out and do an observational study at Wake Tech, and I could find out that 15% of the people at Wake Tech have blue eyes. You know what? That's an observation. What you do is once you start saying those blue eyes affect this or that, you've moved on from a simple observational study, and now you're talking about something more along the lines of a correlational study or an experimental study. And then you'll have to look and see whether or not the two groups, there is a control group and an experimental group, and whether or not there is random assignment to determine if you can suggest causality. Did that make sense to anybody? If you would, please give me some feedback in the chat bar and let me know that I made sense. Okay. So, like I said, you're all going to get a chance. Okay, fantastic. And I don't mean to frighten you off by failing your first writing assignment, but one of the things that I am looking for you to understand is to appreciate how people collect facts and how they use those facts to support conclusions. So you might have a friend that says, hey, I had an uncle that took the COVID vaccine and he died of a heart attack 3 weeks later. That proves that the COVID vaccine will give you a heart attack. No, that's just a case study right there about your uncle. Or another person might say, my aunt didn't take the COVID vaccine and she died of COVID 3 weeks later, suggesting that and therefore the COVID vaccine could have prevented her. Again, that's faulty reasoning based upon a case study, or what you might call just an event that happened in your life. And so anytime people throw data at you or throw results at you in the world, and you're going to read them every day, you're being bombarded with scientific facts and conclusions on websites from relationship professionals, from diet professionals, from everybody. And what you need to do is to think about the research methods that are using and whether or not they can truly make the claims that they say they can make. So focus on descriptive, correlational, and experimental methods. Oh my God, that was so boring. I am sorry. Was I preachy there? Again, the idea of this class is not for me to tell you what's right or wrong, but to give you the tools yourself as a student so that you can go out and discern right from wrong or correct from incorrect on your own. That's more valuable skill than just learning to parrot what your instructor says. And you are welcome to disagree with me at any point in this class, but be prepared to defend your point of view with data. The instructor is not always right. Authority is not always right. What they have to do is prove it and use the scientific method is one great way of proving this. Ooh. All right, let's carry on to the next subject. So we're going to talk a little bit about iRobot, cognition and the rise of artificial intelligence. So this week's lecture, I'm sort of talking about things that make computers and humans similar, and things that make humans and computers different. Now, I sort of pitched this to you in the terms of this rise of artificial intelligence because it's kind of sexy and scary. Will AI destroy the world? Who knows? Maybe not, but probably not anytime soon. But I wanted you to know that modern psychology was very influenced by this idea of the computer. And the computers and the development of computers were very interested in trying to understand how humans reasoned as well. So the cognitive perspective, the biggest, most powerful perspective in psychology right now, where most research psychologists are practicing using cognition research, these people are all really, really focused on the ways in which human beings process information and how that's similar to or different from computers. Now, when we talk about will AI rise up and overthrow us, is AI going to become sentient and develop a plan to destroy human beings? Now, if you've ever watched Terminator or The Matrix, you might have some crazy ideas about whether or not that's going to happen. Now, theoretically, I guess it could happen. However, it's probably not going to happen anytime soon. So let's go ahead and move on to our lecture if we can. Number lock. Oh, number lock. There we go. All right. So one of the first things that artificial intelligence did, the invention of the computer started this huge arms war with the military, where the Defense Department wanted to figure out if they could program computers to do what humans did, faster, better, more efficiently, do things that maybe human beings couldn't do. And so the Defense Department, the United States Defense Department, threw a ton of money into artificial intelligence research, trying to get computers that could problem solve and do things. One of the first areas they focused on was solving problems. That's the simplest things that human beings do, is we play tic-tac-toe, or we figure out how to move this box over there, or we figure out how to fix this flood or that thing. We learn to solve problems. So that's the first thing the military really started paying for. And the research blew up trying to create computer programs that could solve problems. Now, there are two ways to think about computer intelligence. If you were going to try to create human intelligence with a computer, the first is you could use what's known as the symbolic approach, which is where you could try to write the complete program that does everything that you need it to do. Think about Microsoft Word, that program that you use every day. That is a symbolically derived intelligence program. It was designed to do a certain set of features that are said to be what you need to do to create documents, right? And so anytime you've ever tried to create a document, there's a program which shows you how to make headers. There's a program that controls when you want to change font, right? So in a sense, Microsoft Word was created by somebody who programmed all the options you might need and then set that program working. They debugged it, and now that program does whatever you want it to. That's a symbolic approach. The second way to think about intelligence is to think about a connectionist approach. And that's where you give the program a few basic sets of rules and a process to use induction to, in a sense, learn from those rules. And then you send the computer in, and it starts off dumb and gets smarter as it works and forms connections between right and wrong. Do you see the two ways to think about programming a computer, sort of the symbolic approach versus the connectionist approach? Well, the early approaches to artificial intelligence sort of fell into this idea of, well, let's program computers to know everything from the start, just like adult problem solvers do. And you'll see there are a lot of different symbolic methods to problem solving. And I'm not going to bother going over each of these approaches, but each of these are different ways when confronted with the problem, you can program a solution to it. So trial and error says try everything till something works. Heuristic says try something that approximates this initial picture. And so you can come up with different approaches. And what these symbolic people found was that they could create computer programs that could solve problems just like human beings could. The only problem was each of these programs was only good at solving one type of problem. And you folks and I know that problems come in lots of different shapes and sizes, and some solutions don't work in certain situations, and different strategies are required for different problems. Well, the deal is, as good as computer programmers were at programming a computer to solve one problem, what they couldn't do was create a computer program that could figure out which problem solving approach was needed and to apply the appropriate one in different situations. There's a certain flexibility of human thinking that allows us to float flexibly from one problem to yes, 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 that's exactly what it is. And that's a brilliant insight that the first programming people hadn't learned. In 1950, they were like, oh, we have to build a perfect algorithm to solve the problem. Nobody had stumbled onto the insight that no, computers have to learn like humans, right? So they had to figure out how it was that computers were that were better than humans. Isn't that weird? So in some ways, a computer is way better than you. It can process numbers so much faster and it can do things. But you can learn and sort of program, and you have the ability to understand these things called concepts, which are underlying abstract relationships among bits of data. That may make you a little bit different too, but you're definitely on to the right idea, Sandeep. Now, the failure of this symbolic approach was horrific and embarrassing, and it led to what was known as the artificial intelligence winter. And if you look at this link I have at the bottom of this page, what you're going to see is that artificial intelligence has waxed and waned in terms of its importance and whether or not we think it's going to change the world. And you're going to notice that it was predicted several different times and it hasn't happened. What we are in right now is a time of waxing interest in artificial intelligence because there have been some stunning successes with the connectionist approach. And people now feel like we are creating this programming language which can approximate being a human. I don't know if it does. There are still gross limitations in what artificial programs can and can't do. And you'd be surprised how the amazing things that a 3-year-old child can do that the biggest supercomputer can't do because of these weird sort of contextual, conceptual cues that we appear to have. So problem solving. One way in which I can tell you that humans and that AI may not be ready to overtake us, all right? The second is now, one of the things you can go into ChatGPT right now and you can ask it a lot of questions and it's going to answer your questions very eloquently and it's going to lead you to ask the question, does ChatGPT, does it really have the ability to converse? And when you're talking about using conversation, you're also talking about the abstract thing called thinking that goes on. Because when you're talking, you're representing what's in your mind, you're responding to somebody else's mind. So really, if you think about it, language is a very complex ability that reflects our ability to conceptualize objects and then to spit them out in some sort of logical order. Now, the famous linguist Noam Chomsky in 1950 was so convinced that human beings had sort of, if you will, this nodule or this receptive ability for language that he created the term language acquisition device. There is not actually an object in your brain called the language acquisition device. Instead, it's a metaphor used to describe your almost amazingly magical ability to learn at least one language if exposed to it early in life. And there's actually, you can learn more than one, and I'm not sure what the limit is on the number of languages that you could learn if you started early enough in life. But human beings have this natural ability to just suck up language without even trying. Now, if any of you are in a foreign language class right now, I'm actually trying to learn Spanish at age 53. Buenos dias, señoras. And it's a pain, and I'm suffering, and it's very hard, and I put a lot of effort into it. On the other hand, a 2-year-old, a 1-year-old learns A, without being taught, and B, without even really trying to learn. How amazing is that ability? We have this natural ability. Again, Sandeep, like you mentioned that comment about this children's problem-solving ability, almost like we have this ability to build a set of problem detectors based on the situations in our mind. We have this ability to build language. However, and you should read this because it is going to be important for your writing assignment, the Jeannie Wiley case study. The crazy thing about the brain is these, especially if we have innate abilities, these parts of our brain have to be stimulated at the right time in order for their ability to develop. Otherwise, if you don't stimulate that part of the brain, it will find something else to do. Now, there are lots of critical periods, and we may even talk about one. God, I have so much to talk about in webinar, but not enough time. But it's weird. There are lots of different critical periods for vision, critical periods for talking, critical periods for learning how to love. And these are periods which, if you don't stimulate a human capacity like they're seeing or they're speaking or hugging another person, the part of the brain that does that and wants that and thrives on that will wither away and do something else. Same thing with language. We all have this innate capacity. But if you aren't exposed to language, and believe it or not, there have been a couple of case studies of people who have not been exposed to language, and they pose an interesting question. Is there a critical period for language learning? Now, watch the Jeannie Wiley case study, but remember, you can't assume too much based upon her case study because you don't know, is she like every other child in important ways, right? Now, so that's sort of an interesting thing about language is that we have this innate ability. Now, the thing with language, no, 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 no. And that's what I'm getting that emotions on the next slide. Funny you should mention that. That's the next slide. Sandeep, you're on the money here. Let me make one comment about language. Here's the difficulty with language. Now, you can program language because language can be broken down into a bunch of symbolic parts. For example, language is composed of phonemes, morphemes, a lexicon, grammar, and grammar. So you have sounds. These sounds go together. When you put the sounds together in the right way, they form this thing called a unit of meaning. These unit of meanings, there is a list of these unit of meanings that we all agree on: box, book, dog, right? And we know the set of rules that allow us to program these symbols together in the appropriate order, right? Subject, verb, object. That's a set of grammar for the English language, right? Now, here's the weird thing though. There's something else in the system that the computer maybe doesn't know. And this is what we'll call the conceptual level of learning, the understanding of the relationships between objects, because green and grass can be related, and green and an emotional state called envy can also be related, and green can also be related to fungus on your foot, you know. And so there are lots of these abstract relations that we learn that aren't really programmed, if you will. Let's call them the deep structure of language. And the crazy thing is, if you rely just on surface structure, on programming an algorithm and a set of rules, you can write ridiculous sentences like the one below. Colorless green, ideas sleep furiously. That is a perfectly legitimate sentence in the English language, except each and every one of you knows that it isn't. And so one of the things we have to think about when we program, when we ask AI questions, chat GPT question, what we have to do is we have to ask ourselves, is that question is its answer based on knowing how to algorithmically program the correct responses to the target words we provide? Or is ChatGPT, does it really understand? Does it understand on the conceptual level? And I don't know if artificial intelligence understands on the conceptual level just yet. Now, I'm sorry, is everybody still following me? Is this interesting? Does this make any sense yet? Any sense? Give me a little feedback if you could. Sandeep's blowing my chat up, which is good. Thank you very much, Sandeep. But is anybody else still here with me? If you are, give me a quick shout out. Now, as Sandeep mentioned, one of the other ways in which we have to think about the differences between humans and artificial intelligence and human computers is in terms of directionality, okay? Think about your computer. Your computer will sit on your desk from now until eternity. Your computer has no motivation to do anything, no desire to do anything. Your computer isn't going to get bored. Your computer is there to compute when you ask and what you ask. Your computer program has no motivation or emotion. Now, one of the things that makes you different from, and I think better than computers, and one of the things that I think makes life worthwhile, it creates love and joy and sadness. It created the blues, man, are motivations and emotions. That is to say, human beings have a sense of agency. We want to do something. And this sense of agency or motivation is created by feelings that things give us. My mom makes me sad, so I go away from her. My girlfriend makes me happy, so I go towards her. Uh, Pepperoni pizza smells tasty, so I go towards it. You know what I mean? So the difference between a human being and a computer is this sense of agency, this sense of motivation. And you can think of this sense of agency as being combined in two things that human beings talk about called emotions and motivations. And if you look in your chapter 10, what you're going to notice is that motivation and emotion are put together. Now, I like contrasting them with the computer approach because a computer approach is so much about logic. But you know what? Human beings are not about logic. Human beings act from, if you will, a motivational point. Now, if you remember from the first lecture when I was talking about old philosophical theories of human functioning, if you'll remember, the ancient Egyptians thought the human being was controlled by the heart, right? And so they had a cardiocentric theory of human functioning. And it wasn't until the later Greeks where they would say, you know what, it's probably the brain and not the heart that controls the human being. Now, let's think about that cardiocentric theory 3,000 years later. What exactly were the Egyptians trying to capture when they believed that the human being was controlled by the heart and not the brain? What exactly do you think was most important in the Egyptians' view of human functioning? What were they focused on? They were focused on motivation and emotion. So the crazy thing is the ancient Egyptians were dead wrong thousands of years ago in one way, but we still talk about following our heart when we're doing something we really want to do, that we're motivated to do, right? So we follow our heart. There's a mini robot toy. When you slap him, he will react aggressively. And when you love it, he will, whoa. Okay, Sandeep, you got to send me a link to that toy. These people are trying to create a motivated robot. That's creepy and cool at the same time, and I haven't heard of that. So you are now required to send it to my email. You're now required to send me that information because I won't be able to go to sleep without it. Okay, Sandeep notwithstanding, though, actually, when they program, you know what, let's not. I could go down a rabbit hole talking about Sandeep's interesting idea, but I'm not going to do that. All right, let's think about the brain real quick and how it controls the nervous system. Right now, there are two structures that are really important. Actually, let's think of let's four structures. Let's say in the brain, the limbic system, and the limbic system is sort of the emotional center of the brain. Now, the thalamus is the part of the brain that makes you aware of things happening to you. When you become consciously aware of something, it goes through the thalamus. So that's sort of the first part. You have to become aware of something before it can affect your emotional state. Now, when something affects your emotional state, it activates when it comes through, and it scares you or makes you happy. It activates your fight or flight emotional center. It provokes a strong response. It's going to activate your amygdala, okay? And your amygdala is then going to do two things. It's going to, actually, let's say your amygdala is going to do one thing. It's going to communicate with your prefrontal cortex. But the first thing your amygdala is going to do is it's going to activate your hypothalamus, which is going to start that fight or flight response. And we'll talk about fight or flight and the stress response later. But you folks probably know what we're talking about with a fight or flight response. And so your amygdala is going to kick off an emotional state. If you perceive something comes through your thalamus and you're aware of it, okay, we don't get mad when we're asleep because nothing gets through our thalamus. We're not aware of it. So it gets through your thalamus. You're aware of it, and it causes you to either be happy or scared, you get that basic emotional response. Your amygdala is going to kick off a stress response. Now, here's the deal. Human beings are different from animals in that we have evolved this secondary structure in the front part of our brain called our prefrontal cortex. And this prefrontal cortex is connected to our amygdala, okay? And it allows these two senses to sort of coordinate together so that we can evaluate the things that scare us a little more closely to make sure that they are really scary. I've got a bird feeder out here. And every time I go out to feed the birds, they run away. They're totally frightened from me. Now, I am the one that puts the food in the bird feeder. And yet these birds still don't know that they shouldn't be afraid of me. Because when they notice me, their thalamus notices me, their amygdala kicks off, and they go into the fight or flight response, and they fly away. Now, if they had a prefrontal cortex, this human part of the brain that allows them to store and coordinate memories, they would say, hey, wait a minute, this dude's come out of here a bunch of times and he's never hurt us. We shouldn't be afraid of him. And so the birds should just flutter up a couple of feet and let me fill the bird feeder in before they eat. But these birds don't have the ability to do that. Human beings have a connection between the frontal lobe and the amygdala that allows us to mediate and moderate, that is, to change the final effect of the emotions we feel. Now, if you folks have ever been around a 1-year-old or a 2-year-old, they can throw temper tantrums, right? Now, a temper tantrum in a 2-year-old is normal because that means their prefrontal cortex and their amygdala have not connected together. As you train your child to control their emotions in the ones and twos and how not to cry, those two parts of the brain will connect and they'll learn to control their emotions. And that's why 35-year-olds don't lay on the ground and throw temper tantrums. It's because their frontal lobe has controlled that. Now, have any of you ever met somebody who has a really bad adult temper? They might have what we call an emotional problem. They have anger issues. If you've ever met one of those people, it could be because they're Phineas Gage. See this picture right up here above me. He had that railroad accident that blew out his orbitofrontal cortex, and then he didn't have a part to control his emotion. Or sometimes people just don't learn how to control their emotions when they grow up. Their parents don't train them. You have to learn how to connect those two parts of the brain. So anytime we have an emotional experience, it goes through our amygdala and our frontal cortex. Now, this is going to be important for those of you who have anger problems like I do. I have a bad temper. It's something I've worked with my whole life. My first thing is to fly off the handle because my amygdala fires up. I have to work really hard to stop and focus on what the event means and ask myself, does it really bother me? Because my trigger flips real quick, and it takes me a while to control my initial emotional response. Does that make sense? Now, the thing is, emotions simply allow us to code events in our life and give them meaning. If something happens, I have a positive feeling, a positive emotion. That emotion, remember when we were talking about, yesterday when I was talking about, remember when I was talking about schemas? Mom, right? Birthday card. She sends you a birthday card. She feeds you. She says, I love you, right? So she does all these things. And you know what you have? You have love, which is an emotion. So in a sense, what I'm trying to argue is that emotions, positive and negative feelings, actually serve, if you will, as cognitive markers to help you navigate your world. When you do something and it makes you feel ashamed, then you attach a negative emotion to that behavior. Hopefully, emotions help guide, if your emotions are working correctly, your emotions serve to tell you what it is you like and don't like. They allow you to police your own behavior. And if you get good at reading other people's emotions, and human beings are good at reading other people's emotions, you can learn to evaluate your behavior by seeing what emotions they cause in others. Does that make sense? So the weird thing with emotions and how they make us different, and hopefully Sandeep's robot won't get us too soon, is they allow us to coordinate our behavior as a social species by following the things that make us good, make us ashamed, make other people mad, and we can coordinate our behavior more effectively and have better social interactions. How many of you recently have been really upset by somebody doing something, a stranger doing something rude or careless or thoughtless, something they should be embarrassed to do, something they should absolutely know would piss you off, right? How many of you have had, people talk about how society is getting less civil and people are doing things without regard for other people's emotions. Think about emotions as the thing that guides this agency machine, right? I'm a defensive kind of person. There you go. And emotions can become sort of set ways of perceiving the world. Great idea. Quickly. Your book's going to talk about it, so I'm going to talk about it. The neat thing about this idea of understanding the link between our physiological feelings, your face getting red, your heart beating faster, and our thoughts, even before we had neurological research to suggest this, hundreds of years after, or 100 years after, people were talking about the link between cognition, the way we think, and the way emotions feel. Okay, and so I'm just going to introduce you to some theories, and the last one really is the most important because it's important to our stress response. But this guy, William James, we talked about him in chapter 1. He thought that emotions, because when we get scared, he thought that here's what happens. You see a snake, your body, your eyes see the snake, and it causes your heart to start beating and your lungs to start breathing. And he argued your brain then interprets that physiological response and gets scared. So according to him, every emotion has a physiological response. When you feel that physiological response, you then have the thoughts that are associated with that emotion. So according to James, if you wanted to know how people developed emotional responses, their body would act one way, and that would then cause their mind to act a certain way. All right? And this is called the James Lange theory of emotions. Now, this other guy named Walter Cannon, you may have heard of Walter Cannon because he coined the term fight or flight response. He actually wrote a scientific paper on voodoo death, if anybody's interested. But Walter Cannon had a different theory. He said, you know what? When something scares somebody, they have the physiological response, but the thought comes at the same time. Okay? So James Lange would say that your body causes your emotion, your mental emotion. James Lange said, nope, they both occur at the same exact time. Now, the neat thing or the similarity between these two theories is that they argue that there's no alteration of these emotions. A certain set of physiological responses will cause a certain emotion. That's what James Lange says. It's cause. The physiological response causes the emotional thought. On the other hand, Cardinal Cannon-Bard said, well, the physiological response and the emotional and the thought occur at the same time, but they are inextricably locked in that these physiological responses occur at the same time that these thoughts do. This really cool guy in the 1960s named Stanley Schachter said, you know what? Sometimes feeling excited, happy, and fearful are actually the same physiological emotion. What's different is that we interpret them differently. So when I'm at a football game and it's 2 minutes to go and my team's driving to score the winning touchdown, my Tar Heels are driving to win the scoring touchdown, my heart's beating, I'm sweating, and I'm breathing, right? And my pupils are dilated, but I'm not scared, I'm happy. On the other hand, when a bear comes out of the wood, my heart starts beating, my breathing, it goes, speeds up, and my eyeballs get bigger. That's the same physiological response. It's just a different situation. And so Stanley Schachter set up this really cool experiment where people would come into a lab and he did this experiment where he would give everybody a pill. Sometimes it was either a sugar pill or sometimes it was an adrenaline pill. Now, adrenaline makes your heart beat faster, right? Now, when you gave people and then when they were in there, he would give them the pill and tell them to wait for 15 minutes, and he'd put them in the room with another person. And he found when he gave them the sugar pill, their behavior didn't change based upon the other person. However, when people were under the effects of adrenaline and didn't know it, if the other person acted happy, that person would act happy. If the other person acted sad, that person would act sad. So for the first time, Stanley Schachter said, yes, your emotion is partly the way your body responds and it's partly the way your brain thinks. But those two things don't always have to follow. Just because you're breathing fast and your face is flushed doesn't mean you have to have angry thoughts. Do you see that? Those two are not inextricably linked. One of the things I've learned in trying to deal with my anger problem is sort of conceptualized in Schachter's model of emotion, and more specifically Lazarus cognitive mediational theory of emotions. Your emotional response depends upon the way you learn and habitually see an event. If people cut you off and you learn to take it personally, like me and Sandeep, if you are defensive and you think that people are out to make you angry, then you will be more likely to respond with an angry emotion. And that's what I do. That's what Sandeep says they do, and that's what we need to work on, right? And so if you want to learn how to deal with stress, what we have to learn how to do is when things happen to us, we have to learn how to reevaluate the meaning that those things have for us. Most of us who have stress problems or anxiety problems or depression problems, what we do is we engage in overly negative evaluations, habits of evaluation. You tend to see everything as negative. You tend to see everything as fearful. And so these are sort of one of the things we're going to begin to see right now is that emotions are important because they help direct our behavior, right? And emotions are physiological, but they also relate to how we tend to perceive and respond to things. And so if you want to be a healthier person, if you want to use your emotions for good rather than being self-destructive, what we have to do is to understand how they work, physiological and cognitive, and then we have to learn to train ourselves the way we can. You can't train your amygdala. It's going to happen. It's going to do what it does. What you can do is learn how to change the way you tend to perceive events. Hopefully everybody understands that. Please give me a shout out if you're following. Sandeep says the robot that's going to take over the world's name is Cosmo. That makes me very, very afraid. Okay. Now, reading emotions is incredibly important. In fact, I don't know if you know this, but human beings have a special space in their brain that's designed to save our memories for faces. It's called the fusiform gyrus. It's this little spot in your temporal lobe, and it's where we store information for people's faces. You ever notice how it's really easy for you to remember somebody else's face, but you can't remember their name? How often do you run across somebody and say, wow, I recognize you, but I've forgotten your name? And we always tell people we have a really bad memory for names. Nope, you don't have a bad memory for names. You just have a spot on your brain that makes you super awesome at faces. Human beings need to be able to recognize faces and need to be able to respond appropriately to what other people are feeling. Now, there are actually one of the characteristics of the autistic spectral disorder is that these people have difficulty decoding and interpreting other people's emotional responses. Either they don't pay attention to emotional cues altogether, or they can't interpret them properly. But you're going to see that in people with autistic spectral disorder. There's even another less common disorder. I'm going to type it in the chat bar real quick. You might want to look up. Hold on. Called prosopagnosia, which is called face blindness. Some people can't even recognize their own families, even though they've lived with them for their whole life. It's because they have damage to their fusiform gyrus. So being able to read faces is incredibly important for your ability to be a successful human being. So if you said, Dr. Roddenberry, can I turn in my assignment late? And I say, is it okay for you to turn your assignment in late? No. On the other hand, if you say, Dr. Roddenberry, is it okay if I turn in my assignment late? And I go, is it okay? Absolutely. You're reading my emotion. Your emotions are a very important part of your communicative channel, both sending and receiving. Cool guy named Paul Ekman, who is the world-renowned expert on detecting deception. I don't know if he truly can, but the FBI and police departments around the world believe that this guy is great at spotting deception. So you should watch his TED Talk. He's got a couple of TED Talks and some other videos where he shows his tricks for spotting deception. But Paul Ekman is really famous for I think this was in the 60s. He took some pictures of people in America. And I think he went somewhere in Africa, to the deepest part of Africa, where people had never seen Caucasians or Europeans or Americans or media or anything. And he showed them these pictures. And what he wanted to know was, can these people tell accurately what emotion this person who comes from an incredibly different culture comes from? Somebody I've never, ever met. So, and he did the exact same thing. He asked them to convey emotions, took pictures of them, and brought them back. And what he seemed to find out was there appeared to be 7 basic emotions that people can decode around the world. Now, this is not experimental proof, but this is highly suggestive of the thought that somehow or another facial expressions like smiling and frowning are biologically wired and evolutionary in nature. Maybe we have a gene that codes us to know when we're happy to raise our smile up, or when we're angry to furrow our brows, something. This sort of suggests that there may be something universal and innate in our ability to decode emotions. So he says these are 7 universal emotions. Some people disagree with him. His proof isn't all experimental. He has a lot of suggestive, observational, and correlational data, but proof is another matter. Now, one of the things he does know is that although emotions are universal, everybody in every country smiles the same way and frowns the same way. What he did find was that there are cultural rules about when you display a certain emotion. He called these display rules. So, for example, in some Eastern countries, he would note, if your boss is reaming you another one and telling you how bad you are and what a crappy employee you are, you're not supposed to look sad. You're supposed to look smile, like you're enjoying the talk. On the other hand, if you say that to me over here, I'm allowed to look like a whipped dog, because it's an acceptable thing that you can do here. Okay, and so there are different ones. Now, one of the things, it's not in the book, it's not in the class, but one of the, in order to provide interest, one of the things that Paul Ekman argues, he actually, along this fast and slow emotions, he argues that people's true emotions slip out in these things called micro expressions that last for a half a second before our brain recalculates and changes the emotion. Remember, I talked to you a slide ago about this idea of emotions. Now, in a sense, for most people, because we are feeling in our mind what our body is saying, our emotion, our physical emotion, cognitive emotion, and our thinking come at the same time. And so we make an emotion and we keep it. So if I'm happy, my brain says happy, my face is saying happy, and my happy stays there. But what he argues is that when somebody's lying, okay, and you ask me if I did something for just a half a second, that amygdala is going to kick out the real emotion before I use my frontal lobe to push to hide that emotion. And so what Paul Ekman says is he can spot micro emotions that allow him to detect when somebody is lying. Really cool stuff. Now, I have run completely out of time today. I'm going to go for 10 more minutes, but I'm running out of time. Emotions, that is in a sense, the brief feeling of positivity or negativity that you feel day to day that buffers you around. You live in a sea of emotions, positive, negative, positive, negative. Another way to think about emotion is in terms of the agency of a human being. Human beings have a direction. Oh, yes. Well, if you buy into Paul Ekman, I can't tell you exactly what the truth is, but what I can do is I can tell you when you are attempting to hide an emotion. I don't know if it's real, but the FBI and police organizations give this dude lots of money. So again, Sandeep, as I mentioned at the beginning of this class about research methods, you really need to dig into what he says and see if he convinces you. But he's convincing enough that he's in an introductory textbook. Go figure. All right. But actually, this stuff is in the textbook, but is emotion reading stuff I don't think is in the textbook. Maybe that tells you something. Good question. Last couple minutes. Human beings have agency. All of you are in school because you want to get a degree. You want something out of life. People fall in love because they want something. People go to work because they want something. Human beings have agency. Your computer will sit there until you tell it what to do. It doesn't want anything, but you do. Now, human beings have agency. In psychology, we call this motivation. And we know that motivation activates our behavior. It gets us started. It gives us a direction. You didn't go to fireman school. You came to Wake Tech to go to college. That's your direction. If this is your second or third semester, your agency, your motivation is sustaining you. And you know what I've found? Some students really don't care about getting their degree, and some students are going to die if they don't get their degree. So if you want to talk about motivation, you can say it is that force that activates us. It directs us in a certain direction. It sustains us in that direction. And we have to admit that people have different motivations, and these motivations differ in strength. One basic way of thinking about motivations is in terms of intrinsic and extrinsic motivation. You folks are here because you want an A in my class, and that will allow you to get a certificate. You want something you don't have. That is, you are extrinsically motivated. Now, some teachers wish that you were here for love. Maybe one of you, maybe one student a semester wants to be in my psych class because they love psychology and they can't imagine a world without thinking about psychology. That is what we would call extrinsic motivation. All right. Now, let's be clear here. I know none of you are here because you love psychology. You need a degree. You may like my class, but you need a degree, right? And so think about that. All the things you do in your life, what things are extrinsically motivated and what things are intrinsically motivated. You write some problem. Oh, no. Okay, good one. No, Sandeep, that's a little bit farther than the science would take it. Yeah, now I'm not saying that Babaji can't. That's pretty interesting, and thanks for sharing that. But this guy would just say he can tell when you're trying to hide the fact that you actually hate the person that you say you liked. Okay, quick. We are running out of time. This is actually not in your textbook. I took this from another textbook, but it's really good. One way of thinking about the theories, there have been lots of theories over the last 100 years about why people are motivated, what motivation is. And there are 5 sort of basic categories. Most of you are here because you want a degree. You are incentivized. You go to work because you make money. If you have a certain number of sales, you get a bonus. That is incentivification, an extrinsic model of motivation. However, people do things because they have internal needs. Some people need to feel powerful. Some people just need sex more than anything in the world. Some people just feel like they need drugs. Some people need love, right? They're just driven by these internal needs. A lot of biological systems in the humans are what we call drive reduction systems. Your body gets hungry, you eat, the hunger goes away. That's a drive reduction. You get thirsty, you eat, the body gets unthirsty. That's drive reduction. You get cold, you put on a big jacket and you get warm, and now you're not cold anymore. Those are drive reduction theories. Is to feel fulfilled in the world. Interesting point. Thank you, Nalisa. Nalisa says that a huge factor in the world is the need to feel fulfilled. And I would say that a lot of people in the world are sort of unfulfilled. You can approach that lack of fulfillment 2 ways, Nalisa. Some people would say optimal level of arousal. People are bored. Okay. And if you think about it, nobody wants to be bored and nobody wants to be terrified. We want our job to optimally arouse us. Or what Nalisa is talking about is Maslow's hierarchy of needs. Nalisa, it sounds like you may have heard this. He talked about self-actualization, that need to fulfill one's full potential and achieve their personal aspirations. Now, Maslow argued that we have this need. Now, the other theories that we skipped over, Adler, Freud, Karen Horney, and this need for achievement, all suggested that human beings are driven by these basic singular needs. So Sigmund Freud said it was all about sex. Alfred Adler said it was all about power. Karen Horney said it was all about love. And the need for achievement theory that we're going to take a test on later said it was all about people's need to make A's or to feel good about themselves. These are all individual needs. This guy Maslow said, you know what? Actually, all of these things are important. People need food. They need to be safe. They need to feel a sense of belonging. But Maslow argued that once people have achieved all of that in the 21st century, most of us have our physiological safety and belonging needs taken care of, but we need to feel good about ourselves. And Nalisa would probably talk about that. You know, there are 8 different topics I'd love to talk about in tonight's webinar, and I only get 1 hour. So it's going to kill me. The hardest part about planning tonight's webinar is to figure out what it is we're going to talk about. I have run out of time. Go ahead and read about optimal. Whenever anyone answers my question, someone listening to me, right? Okay, so in a sense, what Sandeep is, you know, you're talking about, well, we could talk about it different ways. If I wanted to talk about a Karen Horney, I would say it's your need for acceptance. Or if we talked about Maslow, I would say it's your need for self-esteem, for esteem, Sandeep. But clearly in you, as in me, I have these, I can get defensive. I have little man syndrome sometimes is what they say because I'm only 5'6", and I'm ready to fight at a moment's notice if I think somebody's disrespecting me. The question is, where does that motivation, and Sandy, which of these models do you think you would put your own personal experience in? I am sorry I didn't get to optimal arousal. Maybe I'll talk about that in the webinar tonight. I don't know. But I do hope you come tonight at 7 o'clock. Does anybody have any questions before I log off? Thank you for being so positive, Melissa. Melissa always makes me feel good. All right, cool. Well, then let's follow up. We'll talk more about motivations tonight. What do I feel like mine is to avoid being bored. I like to have fun. I absolutely don't have to do these live lectures and all these webinars to keep my job. And in fact, I don't even get a raise for doing this stuff. The reason I do these weird lectures and I have these cool titles for my lectures and I do the webinar is because I'm totally having fun and engrossed in this. And one of the things I've always found was if I get bored, I get in trouble, Melissa. You know what I mean? So for me, it's staying engaged, maintaining what we will call optimal arousal. And you know what? We'll talk about optimal arousal in sports psychology tonight. Indian time. Oh God, I can't help you out, man. Sandeep, you're killing me. Where in India are you? We are meeting tonight in webinars, 7 o'clock Eastern time. That is 5 hours from now. How about that, Sandeep? We are meeting in Microsoft Teams 5 hours from now. Okay? All right, folks. Thank you very much, Jenna. That's also nice to hear, too. Have a great time, and I'm glad you have a great time. You take care. Have a good rest of the day, and I hope to see you tonight. And Sandeep, I hope to see you from Jaipur, India. Hey, I heard you folks are thinking about renaming your country. We have to talk about that tonight, too. Hey, take care, folks, and I will see you soon. Bye.